let's start. So we're going to talk about objects and classes today. Okay, guys? So we've already been using them. You know, I keep saying this in that with this programming stuff, sometimes there isn't a really nice sequential way to learn all this stuff because you kind of have to know everything all at once, right? Because you saw just to print a message to the screen, right? You needed to use an object, right? You needed to use a class, but you didn't. You may not have sort of understood what you were doing, but we're going to fix that today, okay? So let's zoom back to, let's say, before the 1990s, okay? So the way people, so you know, starting in the 80s, personal computers really took off, right? You could buy a really powerful computer at the time for pretty cheap. This was a new thing. Okay, so development, lots and lots of people were getting into development, and programs were getting bigger and bigger and more complex all the time. Okay, so you can imagine just having a bunch of unorganized commands, it would get really unwieldy after a while. Okay, so what we've been doing, sort of the approach we've been taking to programming so far, you could call procedural. Okay. So what we've been doing is yesterday we just looked at methods seriously for the first time, right? And so what that does is it groups our commands into things that we can name, right? So so procedural, like think of the root of that word, which is procedure, right? What's a procedure? Let's say there was a procedure for turning on the computer, right? What do? You plug it in, you plug the monitor in the computer, and you push the power button, right? So those, you can look at that. Those, it's like step 1, step 2, step 3, step 4, step 5. That's the procedure, right? And that's what we've been doing. So you know, step 1, step 2, step 3, etc. Okay, and then that leads us to whatever we want to, our goal. Okay. So that was pretty much how development was done up until the early 1990s, okay? And then some really smart people came up with a new way, newish, a different way of organizing our code, okay? So rather than organizing it purely along procedural lines, so we just have this, you know, run this command, run this function, run this method, step 1, step 2, step 3 kind of thing, what they came up with was something called object-oriented programming. Okay? So we'll make this big like this one. Why can't I untab that? There we go. Okay? So So now, what we're going to do is now, rather than just grouping our code into procedures or functions that we can call, what we're going to do is we're going to organize our code into something called a class. Okay? And a class is a combination of not only functions or methods, which we've been learning about, but also variables, or the more correct term would be properties. Okay? So rather than just grouping together with functions, we're going to have these blocks of code, these modules called classes. Okay? So this is sort of the old way of doing things, and you know, people still do things a lot this way, right? We don't, even still today, not everything is object-oriented, okay? Sometimes it can take a little bit of work. Like if you're doing a little very quick program, it may not be worth it to set up classes and objects and things. But if you're developing even a somewhat complex system, you really, really need to use objects and classes. Otherwise, your code will just become totally unmanageable. Okay? Okay, so let's look at so aside from let's step back from programming for a second. Okay? Let's just think about what does the word class mean? Right? I don't mean class like where we're sitting, right? I mean class like which is sort of like where's my I guess we could class kind of equals like category in a way. It's a category of things, right? Like, do you ever seen a car commercial where they say this car won best in class, right? It won an award. It was the best in its class, right? What do they mean? Yeah, the best in its category, right? Like it was sports cars or something, and that car was the best sports car. Because you don't want to compare a sports car to an SUV, because they're different. It's apples and oranges, right? So that's what we mean about class, is like a category of people. Okay? So let's think, okay, so they're within a class, so a class has two things. So, and this is not just this is not only referring to programming, but this is just classes in general. Okay? So a class has two things. First, it has what the class or object is. Okay? And the other one is what the class or object does. Okay? So an object is something, and it also does something. Okay? And before I move on with that, I just want to clarify what the difference between a class and an object is, just before, because that may not be perfectly clear. So a class is like a plan or a blueprint. Okay? Think of it like, and a blueprint for a house is a good example. Okay? It has basically the plan of how a house would work, but it's not a house. Okay? An object is the instantiation of the class. So what would be an example? Let's say I had a blueprint for a house. What would be an example of an object of a blueprint for a house? What would be an example? No, the actual house.
Oh, the actual house.
The actual house. Right? Because can you live inside a blueprint? No, you can't. Right? It's just an abstraction. It's a plan. Right? Then the construction people look at that plan and they instantiate that plan into an object, which is a house. You can live in a house. Right? A house is the real object. Okay? So that's the difference between a class and an object. They're tightly related. Okay? Okay. So let's go back to our discussion here about there are two things about and how we can describe a class. What an object is and what an object does. Okay? So in programming, these are called properties. And they are represented by variables. Okay? In programming, what the object does is called its methods, and these are methods, essentially. Okay? So let's step outside programming again, for example. Let's define a class. Let's define a class. Okay? We're going to create a plan for an object. Okay? So let's come up with a class for a car. Okay? We're going to create a class called car. Okay? And this class is going to represent all cars. All cars. So sports cars, economy cars, luxury cars, all cars. Okay? So, what about a car? What are some properties of a car? Right? Let's say you just bought a new car, or let's say I bought a new car. Okay? And you're interested. I tell you, hey, I just bought a new car. What's something you might ask me about it if you're interested? Yeah, what color is it? What color did you get? That's a property, right? That's a property of the car. So color is one property. Okay. What's another property of a car?
Size.
Size. Okay. Like maybe the length and the width. Okay. What else do all cars have as far as properties?
Brand.
Sorry?
Brand.
How? Brakes?
No, brand.
Brand. Okay. So like the make and the model.
Yeah.
Yep. So make would be Ford, model would be Mustang or something, right? Okay. What other properties does a car have?
Engine.
Yeah.
Horsepower.
So maybe the engine size, right? Maybe also the engine type. Okay. What else? What else do all cars have? How about how many doors? Is it 2-door, 4-door, hatchback? Okay. What else? How about what other properties? Let's say fuel type. Now we have some choices, right? You could buy a Tesla now. That's fully electric. How about what else? How about top speed? That's a property, right? How about acceleration? Okay. What else? Can we think of a few other ones? What else do all cars have? How about transmission type? Right? You could have manual versus automatic. And even they have another one now, continuously variable transmission. Have you heard of that? There's no gears. Not important, but... what else? One more thing. I want one more example from you guys of a property of a car.
Size of a wheel.
Yeah, wheel size, right? You could get those big, big tires, big rims, if you want. Okay, so those are properties. Now, all cars have these properties, right? If a car doesn't have a width, like how it has to, it's an object, it has to exist, right? If it doesn't have a top speed or a fuel type, then it probably isn't a car, it's something else. Okay? So this is what a car is. Okay? So, let's say you could have a red Mustang and you could have a blue Mustang. And the only difference would be the color property is different. One is set to blue, one is set to red. Okay? Now, what does a car do? What does a car do? It moves. Okay? So, maybe, so you could say accelerate. Okay? So, and that would take care of braking as well. Because, so if you accelerate positively, you'll go forward. If you accelerate negative, you'll slow down. Okay? What else does a car do? What? Park? Okay, I think that has more. I think we've covered that in accelerate. What else does it do?
Capacity.
Sorry?
Loading. How much loading?
That's what it is. That's a property. A car doesn't do a capacity, right? It has a capacity.
Light.
What?
A light.
Sorry?
A light from the lamp.
Okay, signal.
Sorry?
It's a signal or what?
Oh, yes, turn signal. Turn on signal. Absolutely. Okay, what else? What else does a car do? How many of you are drivers here? Drivers? Okay. Well, you've seen cars on the road, right? What else do they do? What else do they do? Do cars always go in a straight line? No, they turn. Okay. What else do cars do? They reverse. I think it's still, we got that, that's an accelerate. Maybe, okay, maybe you're onto something. Maybe they can change gears, right? You put it into drive or reverse or park. Okay? What else? What else does a car do?
Turn on the lights.
Yeah, turn on headlights. What else does a car do? There might be one or two more.
Music.
Yeah, turn on radio. Play music. Okay? Okay, so I think that's decent. So see how now we've defined, we've set up a template for our class, right? So we've defined what a car is, right? And we haven't actually set the values yet. We've just said, okay, a car has these properties, and when you instantiate it, those properties are going to have values. Okay? And then we've also defined what a car is. Or, I'm sorry, what a car does, right? So, okay, so in a second, we're going to turn this into C# code. Okay? So, what do you think we're going to use to represent the properties? What technique are we going to use? What concept have we learned about that will allow us to implement this part of the class?
Methods.
Nope. Variables. Okay, how about this one? What can we do for this one?
Methods.
Methods. Excellent. Okay. Methods. So methods will, right? Because methods are, think of it, methods are actions, right? It's a bunch of commands, whereas variables, it just stores some information. Okay. Okay. Let me just glance through my notes, make sure I'm just covering everything you guys need to know. Okay, so let's start up a new Visual Studio project, a Forms project. Okay, so new project, and we're going to create a Windows form application. So we'll save this as okay. Okie dokie. So, you'll already notice, see, we've already been using classes and objects already. If we look in this code, view code, form, see how, look, we already have a class. Okay, we're defining a class called form1, and I think we might have some time to talk about inheritance today, but we may not. But we'll come back to it. But essentially what inheritance is means that, so let's say we have a superclass called car, and it has properties and methods common to all cars. Okay? What we can do is we can create a subclass. For example, sports car. Okay? And sports car is going to have some specific properties and methods that the superclass car does not have. Okay? So you can have the sports car inherit all the properties and methods from the superclass. Okay, but we'll talk about that more in detail in a minute. If we see here, here's our class. Okay, we're defining a class, and then we're defining its. So these are its properties in here, and these are its methods. Okay, but what we're going to do today, we're going to define our own class. Okay, we're going to create this car class that we just designed here. Okay? Okay, so what we're going to do is we're going to right-click on our project here, and we're going to create a new file. We're going to say add new item, and we're going to pick class at the top. Okay? And then we're going to call this class car, or this file. Now usually the convention is that the file, when you have a class inside a file name, the file name has the same name as the class name. Okay? Okay. So this is our class. Okay, this, we can define it. We're going to transmit this. We're going to transfer this stuff here. Let me just close this. We're going to transfer this stuff here over into code. Okay. So the first thing we can do, the first thing we need to do is we need to create a method. Okay, called the constructor method. Okay, so the constructor method, I'll put a note here. So the constructor method it's a very important method. Okay, every class, I suppose you don't need one, but you should have one. It's run automatically when the class is instantiated. So when you go from the class, which is the plan, to the actual object, which is the thing. So think of instantiation like building the house. Right? You're using the plan to create an actual thing that you can actually use. Okay? So the first thing we want to do is we're going to create a constructor method, and the way we do that is we create a method that has the same name as the class. Okay? So what are we saying here? I'm writing a method. I've put void here in front of the method. What does that mean? What does that mean when I put void at the beginning? It doesn't return anything. Okay? Usually your constructor will be void. Okay? So for now, we'll just leave this blank for now. We'll come back and we'll fill it in later. Okay? So what we do is we put our class properties, our object properties, right at the top usually. Okay? So let's look at our properties. Our first property was color. Okay? So what type of variable should we use to represent color? String. Sure, that sounds good. Okay, color. What's the next one? Length. So what should we use to represent length? Double. Double. I would say double, because we might want to have a decimal point. And then we also had width. Okay? And what should we use for make and model? String. String make, string model. Okay? What else should we so engine size. So what should we use for engine size? Double, sure. Okay. What else? Engine size. Engine type. What should we do for that? String. Okay. What about how many doors? Int? Yeah, because you can't have half a door, right? Number of doors. What else do we have? Fuel type. What should we use for that? String. Okay. What else do we have? Top speed. What should we use for that? Double? Yeah. So we'll go back here. Double top speed. Okay. And what else do we have? What? The what size? Oh, wheel size. Oh, there's a couple more. We still have acceleration. So double acceleration. And we could always just copy these. Transmission type. What should we use for transmission type? string, right? Okay.
Streets for the wheel size.
Oh, you're right. What should we do for wheel size? Double. Yep. Okay. So if I run and compile this, will anything happen? No, why not? Yeah, I'm just setting up the plan. Member names cannot be the same as their... Okay, let me just... I'm missing something about my constructor. What am I... It's been a little bit here. Let me just... oh, there we go. Oh, I guess I don't... Actually, I don't use the void for constructor. Okay, that should work now. Why isn't that working? There we go. Okay. Okay, so I made one little error. Instead of void, you should put public. And we're going to talk about, maybe not today, but we're going to look at what this means, public and private. Because you guys have probably seen that in your code, right? But you maybe were a little confused. So now that we understand, now that we're starting to understand classes, probably next week we can talk about what that means exactly. Okay? Okay, so we've set up our properties. Okay. Pretty good so far. So now, how about this? What do we do for accelerate? What should we call the method for accelerate? Probably accelerate, right? So what we do is right below, so now we have a class, right, with a bunch of properties and one method. And so what type of method is this again? What's it called? Because it's, remember, this method is named the same as the class. The constructor method, right? And when is the constructor method run? Yeah, automatically when you instantiate the class. Exactly. Okay? So we'll look at that in a minute. We'll once we finish defining our class, we'll instantiate it and then use it. And you'll see we'll go through the code and see how it runs, okay? Okay. So what was the first method we had? Accelerate, right? So we'll make this method public, okay? And again, I'll explain what that means in a minute. And I think for now, we'll probably want void as well, because we're not going to return anything, okay? And then we'll create our method name, accelerate, right? And then usually, so our methods can have, you can pass things into methods, right? Remember we looked at that last week? What were the two ways of passing information into a method? Exactly, by reference and by value. Okay, good. You guys are remembering things. Okay, so what do you think we should pass into the function accelerate? What would that function need to work properly? The rate, right? Because you can, if you jam on the gas, you're going to burn rubber, and if you just touch the gas lightly, you're going to go really slowly, right? So what we need to pass into accelerate is the rate. How much are you going to accelerate? Okay? So what type should we make that value? A double. Okay? And we'll say rate. Okay? Okay, so now we won't actually put anything in the methods yet. We're just sort of designing our class. We'll go in later and we'll fill out the methods. Okay. Okay, let's look at also here. Okay, turn on signal. Okay, so that's another method. So again, we're going to make it public and void because we don't want to return anything, and we'll say turn on signal. So does turn on signal need any input? Does turn on signal need any input? No? Are you sure? How does the car know which way you're turning? Ah, direction. Right? So what type should we make direction? You could make it a string. That might be overkill. Because you could make it a bool, because that's all we really need to know. But conceptually, I'm not sure if that's the best, because really, it's not true or false. It's left or right, which is different. It's a judgment call. I might make it maybe an int. And then right in the method, I'd put a little comment. 1 equals right, 2 equals left. Something like that. What's that? Oh, yeah. Okay, sure. The flashers. Emergency. Okay. Okay, what other method did we have here? Turn. Public void turn. So, do we need anything in turn? Sure. I think for turn, because with turning on a signal, it's a discrete choice, left or right. But with turning the wheel, it's more continuous, right? You could turn the wheel to change lanes, or you could turn the wheel to do a U-turn. So let's make it a double, and let's call it degree, right? So if you're going this way and you turn 90 degrees, right? Now you're over this way. Or if 180, now you're going to turn around and do a U-turn. Okay? Okay. Now, let's think, we need to add a few things to our car now. Okay? So, one thing we need to know is let's say we're building this class because we want to make a game, like Grand Theft Auto. Right? Has everyone seen or played Grand Theft Auto? Right? It's a world, there's cars, or any car game, right? Or any world where there's cars moving around in the world. Okay? So, not only do we have to describe what the car is, but we have to describe like where it is. Right? So we need a position variables, right? So we could have double let's say if this is a real world, we could say lat for latitude, and double long for longe. Right? That'll be longitude. Okay? Then we also need maybe a double called we need something to represent where the car is pointed. Even finer, because we could do it right, because your car just doesn't go like this, right? Like that, right? It kind of you could go like this or like this or like this, right? So we would call it bearing, or yeah, bearing might be. Let me just double check that. Bearing. Bearing. Just want to get the right spelling. Direction, because there's a couple of bearings. Right. So we'll say bearing. Okay? And then also, how fast is it moving right now? Is it stopped? Are you racing down the highway? So we need a current speed. Okay? Okay, let's go back to our methods. Okay, we have turn. So we have degree. What's another method that we have? We have change gears. Okay, so again, public void change gears. And do we need to pass anything into change gears? What do we need to tell it in order to change gears? Which gear? Yeah, int gear. Right? Are you going into fifth, or reverse, or third? Okay. And now let's look at, okay, turn on headlights. Public void turn on headlights. Do we need one for that? Maybe I would say I would have a boolean called high beams. So if it's false, you just turn on the regular lights. If it's true, you turn on the high beams. Okay? So we'll put a note here. False equals regular regular true equals high beams. Okay? This? Change gears. Okay, and what was the last method we had? Oh, couple. Oh, turn on radio. Okay, so now we're going to have public void turn on radio. So what do we have to pass into that for that to work properly? Do we need only one? One parameter? Exactly. So we'll have double for station or frequency, and then double for volume. Excellent. Okay. So now if we compile, we will have our class. Okay, but of course it's not really doing anything quite yet. Okay. So let's instantiate our class now. Okay. So let's go into our form and let's create a button. Okay, and we'll double click on our button. Okay, so that should be old news for you guys now, right? So here's what we're going to do. As soon as we click this button, we are going to instantiate our class. Okay? So think of another way you can think of classes and objects is think of a class like a custom variable. Right? So how we've looked at variables in C#. We have integers, doubles, strings, booleans. But now we can create our own type, our own custom type that can hold many, many variables and also some methods that go along with it. Okay? So this is how we instantiate an object. Okay? So the first thing we do is, and it's similar to how we create a variable, right? So actually, let's create a variable first. Let's create an int, and we'll call it my variable, and then we'll give it a value, 5. Okay? So here we have the type, and here we have the name, and then here we have the value. Okay? So think of this as like the class. So this is a object of class int. You could think of it that way. Okay? So what we're going to do now, we're going to create an object of type car. Okay? And see how it turned light green? That means that it knows that that's a custom-made class. You can access it now. Okay? So just like with the variable, what I'm going to do now is I need to give it a name. My car. Right? My car, it's not yet. Not yet. Right now, it's a reference to the object. But it's not even that yet. So now we have to make it equal something. Exactly. So what we're going to say new, and you may have used this keyword already. So we want a new copy of, see, and it's hinting to us. It knows. See how it's highlighting car? It's saying, well, since you're using a reference of car, you probably want to refer to an object of car. So we're guessing that you want to create a new car. So you say new car, and then you also have to give it brackets. And then you give it semicolon. Okay? So let's do a breakpoint here. Let's just do another, we'll say message box. Whoops. Message box show object created. Okay? So what we're going to do, we're going to break here, and so we'll see the value of my car, and then we'll see it after we instantiate it. Okay? So I'm clicking this button, and so here we are. So my car, see the value of my car equals null. Then as soon as I go to the next line, now my car is equal to an instance. So see all these things now, but they haven't been set to any value yet. Okay? And we don't have access to them yet, so we'll have to do some changing in our class. So does everybody have this now? They have car, my car equals new car. Okay? Okay, so now what we have to do is, so let's actually, I want to show you that the constructor is being run. Okay, so let's go back to, we'll stop the code. Let's go back to our car class. And let's go to our constructor. And let's say here, let's print a message box. Oops, so what we have to do is, so in this class, the library for message box isn't automatically included. So we have to go back to our form, look at our code, and I believe it's Windows Forms. So copy this using System Windows Forms and paste it into the top of your car class. And now this works. See how this is green? So now we're going to go show, and we're going to say inside constructor. Okay? So let's run it now. What's that? Oh, so paste it inside at the top of your car class. So in your car class, you should have using system.windows.forms. Okay. So let's run it. Okay. Okay, see how that comes up first? First it's inside the constructor, then object is created. Okay? So as soon as you instantiate it, as soon as you call this, where are we here? As soon as you call this, it calls the constructor method. Okay? Okay. So is there any questions up till this point? Like any confusion? You're maybe
Assignment 2 is a use class or?
the assignment I gave out last week? No, you don't have to. No.
Well, it's recommended though, right? You're not just gonna put everything in one.
You could. It's okay. It's a small program. It won't. It's not really big
Actually,
enough.
it has 10 options, but 10 online.
Yeah.
What more?
Hmm.
Yeah, mode.
The mode?
Mode.
Okay, we'll look at that.
Mode one.
We'll look at that in the lab.
I only can find it like a single one. If there's like a equal, like even,
You need to use an array.
yeah, the two.
Hmm?
You do use array.
But you use an array. I'll show you how to do it. Do you know what a histogram is?
What is that?
I'll show you. In the lab, I'll show you.
Do you know Stack Overflow, the website?
Yeah.
Yeah, it's useful for getting certain questions.
Oh, absolutely. It's great because the responses are voted on.
Yeah.
So usually the good ones are voted up. Sometimes there's errors though, but it gets you off on the right track.
One problem is that you can't really ask questions like basic questions, like for instance, how do you do exception handling, like the basic question?
Yeah, they're not going to tutor you, but they will. If you have a specific problem, like a little bit of code isn't working, they'll help you out. Yeah. But if that kind of stuff, like how to exception handle, I would just search Google, and then you'll find a tutorial, and that's better. Rather than, I think forum posts are better for specific tasks. Okay? Okay. So, let's start calling some methods. Or actually, first what we have to do is we have to finish our constructor method. Okay? So what we have to do now, we're going to create some parameters in our constructor method. Okay? So, let's say we're gonna create a car. Okay? In code. So in my real world metaphor, that's like buying a car. So let's say you want to buy a car. What's the least amount of information you might have to give a salesperson to get a car that you want?
Price.
No, because that'll be inherent. Make and model, and possibly year. That's another one we forgot. We forgot year. So let's, under model, let's add int. Oh, let's stop our code. Let's add int year. Okay? Okay. So now we're going to add a couple of parameters to our constructor method. Okay? So we're going to take in a string, and we'll call it make. and we'll take in another string, we'll call it model, and we'll take in an int, we'll call it year. And maybe, I think we need one more, which is color. Okay? So now what we're going to do, I'm going to comment out this message box. Now what we're going to do is we're going to take these values here that were passed in, and we're going to set them in the values that come through here, we're going to set them here. Okay? So what we'll do is we're going to use something called the this keyword. This. Okay? So what this means, this is referring to the class. This class. Right? So what we'll say is we'll say this class, the make, so the make of this class equals the make you just passed in here. So this make, so the make that I'm highlighting is from here. The make that I'm highlighting now, that is this dot make, is this make up here. Okay? And so we're going to do the same thing with the other variables. So we're going to say this dot model equals model, this dot year equals year, and this dot color equals color. Okay. So try and compile, you'll get an error. Why do you think we got an error?
Probably because year is equal to year. It's the same name.
Nope.
This.
Nope. But I used the this keyword. So that differentiate. If I did this, that's a problem.
Either static on. You probably have to put a
No, you
static.
didn't put any just take the color. You didn't put any color.
Well, the reason it failed is because here, my constructor's wrong now. It's looking for parameters now. We have to pass in values.
So you have to put the
Make, model, year, color. We have to pass it in now. See, if I run it, it'll say, okay, let's see what the error says. The error says, car does not contain a constructor that takes 0 arguments. Okay? So what we have to do is that we have to give it those arguments, right? So it was make, so Ford, Mustang, 2014, it's brand new, and I like black. My car's black, but I have a Hyundai. It's not very fast. Oops. Okay, so one thing. See here how look, it gives you the definition. See how it says string, string, int, string. But I put a string here instead of an int. So I have to get rid of my quotes. So that should work now. Okay, does everybody have that? So let's step through this. Let's see what happens. I'm going to put a breakpoint here. Okay, I'm going to run it. Okay, press my button. So we stop here. And now what I'm going to do, I'm going to go, see that it says step into. That's going to go into the constructor method. Okay, so I click here. Now we're going into the constructor method. So see now, so the make of this, oh, already? How did it get there that fast? That's weird. No. Oh. That's odd. Okay. That's weird. That shouldn't be. Okay. So here are our values that we passed in, right? And these are our values here that are all null, 0. So we're going to go in. I'm going to press F10. And now we go. So now make, which is Ford, is going to be set here. And now that's set to Ford. And now model is going to be Mustang, year 2014, color black. Okay? So now we can go outside here and we'll continue on. Okay? Object created. But we still haven't done anything really with it yet. We've just created it. It's just like this. We created a variable, gave it a value, but that we didn't really do anything. So that's why we're not seeing anything on the screen yet. Okay? Okay. So what do we want to do now? Let's... So what we have to do is let's go back to our constructor method. Okay. So what we'll do now is, because we don't want to pass, see there, this car has a lot of properties. And remember I said you usually don't want to pass much more than 4 or 5 or 6 maybe parameters on through a method, right? So what we'll do now is inside this method, we'll put an if statement that sets the value of everything else. Okay? So what we'll do is we'll say if model equals Mustang, then so we'll say engine size. So this engine size and this type, this dot engine size will equal what's a Mustang? I think it's 5 liters. What was engine size is a double, so we'll say 5.0. Okay, and then also this dot engine type equals I don't know, what type of engines are there? I guess a gas engine. But even within gas, there are other types. But I'm not really a car guy. Okay, number of doors equals 4. And fuel type equals gas. Oh, this dot fuel type. Okay. And top speed. Anyone know the top speed on a Mustang? Let's say 200. What did I? Is it a double? Top speed is a double. I'll say 200. Okay. And transmission type, we'll say manual. Okay, although that might be different. And then wheel size. How do you measure wheel size? Is it inches? Is 20 inches big? Is that a big tire or a wheel? Whatever. It's just for demonstration purposes, okay? So see, some of the parameters we set based on input, and the others we just set automatically. Let's make this.
For the standard deviation formula, do we use sample or population? Because there's a slight difference, n versus n minus 1.
No, the semicolon, right? So if I know using semicolon, use population.
Yeah, because you know your population.
Also, it's n, right?
Okay. So now when we run our constructor, all of these values are going to get set. Okay. So and also, okay, let's also set automatically. So for all cars, let's make the current speed. What should we make the current speed right off the bat? 0. Right? It's stopped. And also, oh, I gotta say this dot current speed. Or I don't have to, but I will. It makes it more clear. And then bearing. So we'll say bearing. What is bearing measured in? Degrees, I guess? Yeah, so let's say 180. That'll be south, I suppose. 0 is north, 180 is south. Okay? So, let's define the accelerate method now. Okay? So, we're going to create a little car simulation program. And it's going to be really straightforward. The only thing it's going to do, instead of having graphics, we're just going to print messages. Okay? So, the accelerate function, let's say the first thing we'll do is we'll print a message box and we'll say current speed is current speed. Okay? Then what we're going to do is we're going to take current speed plus equals, let's say, rate. We could make this could be a lot more complex, but I want to keep it simple just for demonstration purposes. And then we're going to print another message saying after acceleration the current speed is, and that's what it's going to be. Okay. So if we run that, it's still not going to do anything because we haven't called that method yet. Okay? So keep working on that for a second. Okay, so now what we want to do is we're going to call our method. Okay, so because our method now, before we were associating our methods with classes, but we were just calling the methods from inside the same class. So what we have to do now is we'll say my car dot accelerate, and then we'll give it a number, and there we go. Now we're going to be calling the accelerate method of my car. So it's just going to say 10. I mean, we could go back to the car class and say current speed is, and then we could say plus like kph. Okay. So now when we run it, so we click button 1, current speed is 0, after acceleration current speed is 10. And that's it. Oops. Okay.
What if you really want to use a private class?
A private class?
Yeah.
What do you mean?
I mean, private methods.
Private methods?
Yeah.
Okay, let's talk about public and private for a second. This is a good time. Okay, so you've seen here, right? You've seen it all in your code. You've seen public, private. So what does that mean exactly? Okay, what that means, that sets the accessible, what level of accessibility those variables or methods are at. Okay, so if we look back here, let's look at our car class. Okay, so all of our parameters, we haven't set it to be public or private yet. But let's do that. Let's put in front of all of these, let's put the keyword private. Okay, so in general, it's usually best to keep your parameters private. And I'll tell you why in a minute. Yeah. Okay, so we're going to add the keyword private in front of all of these parameters, variables. Okay? Private, private, private.
Last year I did learn that, but I don't know what's the point of it.
I'll show you. Okay? So, let's go back. So we'll compile this. Let's compile. Okay? And let's go back to our form. So we can access things inside our car object by using the dot. Okay? So notice all the things available here. What can you tell me about all the things that are available here? What's missing? What's here and what's not here? The methods are here. What's missing?
The variables.
The variables. So that means we can't access them like this. So let's go back to the car now. Let's change one of these, the color. Let's change that from private to public. Okay. Now let's look back at our form, and let's click on the button again. Now look what's there now. See how this color is there? So that means we can set the color directly. We could say color equals red. Right? Even though we've set the color here, we can override it because what we've done is we've set this to be public. Okay? Same thing with the methods. See this? Accelerate. The method is public. So if I go back to here, if I put a dot here, I can access that method. See, accelerate? But if I go back here and I change this to private, and I go over here, and now I click here, it's gone. You can't access it anymore. You can only, if it's private, it means you can only access it from inside the class. Okay? If it's public, it means you can access it outside the class. Okay? So, that being said, it's usually good practice to make your variables private. Okay? The reason for that is there's a rule of thumb in programming where you want to restrict access as much as possible. Right? So, for example, let's say if you have a website, okay, you're going to have a database. Do you think it would be good practice to allow your website users direct access to your entire database? No, not a good idea. Who knows who's going to get in there and start messing around, okay? So what we do is we own, let's say Facebook or any site that you log in. What we do is we hide all that database information away. All we allow the user to access is username and password. That's it. Because that's all they need, right? If we allow them more access, who knows who's going to get in there and mess things up, right? So what we do is we hide access from everything that is not required. Okay? The reason we do that is because once our program gets big, we can lose track of what it is that's changing the parameters of the variables. And then our program might behave in a weird way and we won't know why. Okay? So we should always use private member variables. Okay? So, how do we then access them if they're private? What we do is we set up something called an accessor method, a get and set method. Okay? It's like a workaround. And we can actually do, Visual Studio has a shortcut to do that. Okay? So let's say we want a function that will tell us the color of the car. But we don't want to access the color directly. We want to access it through an accessor method. So what we do is we right-click on our variable, and we go to Refactor, and we say Encapsulate Field. And that's the property name is going to be color. And then we click Apply. So see now how it creates this method automatically. So what we'll do is we'll cut this and we'll paste it down here.
I thought in Java you have to write two separate methods. You have to manually only type two separate methods?
That I haven't used Java in a while. That's probably true. I imagine there's probably something like this available now in Java as well. So that it just makes it's something that's done so often rather than typing out two functions. This sort of does it all in one. Okay. So now if we go over to form and we type, now we have this color. Okay, but we're still not accessing the variable directly. This is a method. And the only thing the method does is it sets the value. Okay? So we could do something like this. We could say message box dot show. Oh, so I have to go back and change accelerate to public. So usually your methods are going to be public. Okay. So now if I click here, so I'm going to press this button. So current speed is 0, now the speed is 10, and the color is black. Okay, let me just peek at my notes here. Okay. So let's just get some terms. So there's a client class is the class that is creating and using the object. So can you guys tell me what the client class of this object is? Remember, the client class is the class that instantiates or uses the object. So what's the client class of my car? Form 1. That's the class, right? Okay. So remember, everything in C# is an object. Pretty much everything, right? Because think of this. Even when we go, let's say we make a string. We make a string, my string, and we give it a my string, and we give it a value like this. Look, now we can say my string is an object with many. Look at all the methods we have. All these methods and properties, right? So a string is an object. It's not a simple variable. It's a complex object with many methods and properties. Okay? I believe. Let me see. Yeah, you could do this. String equals new string, like this. The other way. Well, I guess we need to put something in here. Is that going to work? No. So it's going to be like this? No, still not. Too many literal. Oh, we can only give it one? Okay. And then it's just this, okay? So remember, a string is, and this still doesn't work. I'll have to look up the proper syntax for that. But a string is an object. Don't forget that. It's just that they've given us, instead of using the new keyword, they've given us a quick way of doing it, right? My string, and then just putting in the value. Okay. Okay. Let's see. Okay, so I'm going to teach you another concept now. So all of these methods, all of these parameters here are called instance variables. Okay? What that means is they are always associated with an instance of a class. So they are associated with an object. Okay? Static methods. Okay. Where are my notes here? Okay. Creating instance methods. Okay. So what we can also do is we can create variables that are associated with the class. And the way we do that is we use the keyword static. Okay? So now so we could say static what would be a class variable for car? I can't think of a good example right off the top of my head. But let's just create a temporary variable. We'll call it a string, and we'll say it's my variable. Okay? So if you'll notice, if we go back to form, we don't have to, like if we go to my car, that variable is not available. Okay? But if we say car dot, oh wait, why didn't this come up? What am I missing here? Do I have to make it public? Oh yeah, public. Public static string. So now I'm going to go back here, and now it's available. See? So I could say my variable, and this is how some of you did global variables in your last assignment, perhaps. Okay? So now we have, see how we have a variable associated with a class, and also a variable associated with an object.
We use like a form 1.
Form 1? What do you mean? When I... Where? Here?
Yeah. No, you just put it. Let's say you type form 1.
Oh,
Still give
I mean like this, form 1. Yeah, exactly. These are all the static methods and variables available to you. Okay?
For the set and get, what happens if you're on a separate class and then you only want the other class just to get the variable, not try to change the variable? The array, like for instance for the assignment, which is the array, you don't want to use the separate class just to just to change what's inside the array, what's already inside, right?
Yeah.
So you just get rid of the set method. And you just
Or you could just not use it. Or get rid of it. It's up to you. Okay. Okay. So, here's what I want you to do. I'm going to give you a quick little task before the end of class. I want you, let's see, what do we want to do? What kind of class do we want to make? What's simple? Oh, okay. Here we go. No, that's because I haven't taught you inheritance. I think we're going to get into inheritance next week. Maybe. Okay, here's what I want you to do. I want you to write a class called student or college student. Okay? So in C#, create a class that will represent a student. Okay? So what's an example of a parameter, a variable, an instance variable of a student? Gender. Sure.
student number.
Student number. Good. Another one. Name. Yep. Age.
No, wait, birthday only.
Birthday. Sure. What else? Yeah, nationality. What? Major. Yep. Year. Right?
Yeah.
What year are they in? What else? That's probably good. Okay? So write that up. Let me see it. So what's the first thing we have to do? We have to create a new file, right? What are we going to name the file? Student. We always name the file the same thing as the class name. Okay? So we go to File, New, create a new item, and create a class.